Hello everyone and welcome to another part of the C++ video tutorial series. In this video I wanted to show you how you can implement bubble sort in C++. This video will also act as an introduction to a series of videos I want to make about sorting algorithms. So we will be setting up a framework so that we can randomize an array and print it out onto the screen, onto the console, so that we can use those in later videos to compare different sorting algorithms. So let's get started by creating our project. Call this one sorting and creating our main file. So we'll include first IOStream to output things onto the console, and also include time.h, which we will use for randomization. Next up, we can do int main, just create our main function. And the first thing that we need is a way for us to create a random array, because we can't sort an array that's really not randomized, or we end up not doing anything. So let's create a void random array, which would take an int a and an int size, as well as an int max. And max will be the maximum value that this array will have. So for example, if the max is 1000, it would fill up the array with values between 0 and 999. So for int I equals 0, I is less than size. Of course, the size is the size of the array, and I plus plus, a at I is going to be equal to rand modulus max, and that will give us a value between 0 and the max value that we're passing in. Next up is a way to print an array. So let's say void print array int a and int size. And same idea, int I equals 0, I is less than size, I plus plus. And we'll do an stdc out, an empty, well, just a space so that our numbers are not clumped together. And finally, array at I. And all the way at the end, we can do an stdc out of an end line so that we can do a line break all the way at the end. Okay, now that we have this set up, we have a way to randomize our array, and we have a way to print our array onto the screen. So let's give it a try. Const int array size, which will hold the size of the array that we want to sort. Let's give it a value of 10 for now. And of course, our array that we need to sort, which will be called nums in this case. And it will be of size array size. We'll say random array nums array size, and finally maximum. Our maximum will be 1000. So any value between 0 and 999 should do for us. And finally, we'll say print array nums and array size. And there we go. Now we have everything set up. We can do as std_cn.get to keep our console open, to run this to see that our array is actually a 10 sized array with randomized values. So let's run that. There we go. As you can see here, there are 10 numbers, and they are all random numbers between 0 and 999. So how would we go at sorting this array? First, let me try to explain how bubble sort works. Let's use a very small example. So let's say if we have a 1, 5, 2, and 13. What bubble sort does is that it iterates through this entire array, and it compares every two successive values against each other. And if the one on the left is more than the one on the right, in this case it would be the 5 and 2, it would swap these two. So let's walk through it and see how it would work. It would compare 1 and 5 1 is less than 5, so that's fine. And then I would compare 5 and 2. 5 is more than 2, so it would end up swapping the 2. And you would end up with 1, 2, 5, and 13. But of course, you can see that it's sorted, but the algorithm doesn't know it's sorted yet. So since the last index it reached was right here, it keeps going from there and compares the 5 and 13. And of course, the 13 is more than the 5, so no swaps are needed, and it reaches all the way at the end of the iteration. But along one iteration, if it does any swaps whatsoever, it does another iteration. It's only sorted if it goes through the entire array without doing a single swap. Because if it doesn't do a single swap, then that means that every successive value is less than the one after it, and that means our array is already sorted. So in this case, it's going to compare these two. These two are fine, these two are fine, and finally these two are fine. That means that it's sorted, and that would be it. So let's see how we can implement that in C++. We'll create a void bubble sort that will take an array and of course a size as well. Now we probably need a few cases just in case somebody passes in an empty array, for example, of size 0 or an array of size 1, because an array of size 1 is already sorted. You don't need to do anything. So if the size is less than or equal to 1, just return and don't do anything. Now we know that we need to iterate through this until no swaps are made, but we don't know how many times we're going to be iterating until this array is sorted. For that, we can't use a for loop, of course. We end up using a while loop. But since we need to at least iterate through the array once, we end up using a do while loop instead. So let's create a boolean first called swap. That will be equal to false at the beginning. And if we do any swaps through an iteration, we would set it to true. So do while swapped. So as long as you swapped at least once, do another iteration. Of course, at the beginning of the do while, we need to set swapped equals false, because once you start from the beginning, you haven't swapped anything yet. So you need to reset swapped every time. And finally, we need to do our sorting. So for int I equals 0, I is less than size minus 1, and keep that in mind. It has to be minus 1 because you're starting from here, which is 0, all the way to the end, and you're comparing it from 1 all the way to the end. If you go all the way to the end, you would end up from 0 to 13, and you wouldn't have anything after it to compare it to. So we need to go from 0 to the size minus 1, or minus 2 in this case, but yeah, it's less than size minus 1, I plus plus. Okay, so if a at I is more than a at I plus 1, a at I plus 1, so if our value at I is more than the value at I minus 1, we need to swap these two values. And to do this, we would need to create a temporary value to hold one of our values, so a at I. A at I is going to be equal to a at I plus 1. And a at I plus 1 is going to be equal to our temp value. So we're creating a temporary value out here. We're taking a at I, putting it into it, which will be the 5, and then moving or copying what's at a at I plus 1, which is the 2, into here. Because as you can see, if we just copied it right away, we would end up with 2 2s and the 5 would be gone. And then once we copied this over, we can now copy whatever is in the temp back in here. And as you can see, we end up with a swapped value. And after we do a swap, of course, we need to set our swap to true to tell it that we swapped a value. And that would be it. This is all you need to implement bubble sort in C++. Next up, all we need to do is to test it out. So we can say bubble sort our nums with the array size that we gave it, and finally print the array of nums and array size. There we go, and now we can run it to see how it goes. There we go, and as you can see, our array right here is, at first it was a random array, and now it's a sorted array in ascending order. So one last thing that we can do is we can check how many comparisons that we made and how many swaps that we made, how many memory movements that we made. For that, we will need two integers. So int comps, which will be the comparisons, and swaps, which will be how many swaps we made. Of course, right before the if here, we made a comparison because of the if statement. So comps plus plus. And inside here, because we only do a swap inside the if statement, we would do a swaps plus plus. Then all the way at the end of the function, we can say something like std cout bubble sort. Oh. We can say bubble sort comps and give it our comparisons, so it will be comps, and finally swaps and give it our swaps, and then std and l. There we go, and that way we can in the future, when we implement more sorting algorithms in here, we can see how many each of them, how many comparisons they did and how many swaps they did, and see which one is doing better. So let's run that one more time and see how it goes. As you can see here, we did 54 comparisons and 15 swaps. Of course, right now we don't know what that means because we don't have anything else to test it against, but as we go on and create more sorting algorithms, we're going to be using this to compare them against each other, and maybe all the way at the end of the series I will make a video just comparing all these algorithms to see which one does best and when. So I really hope this video helped you out. If you have any comments or feedback, please leave them below. Thank you very much for watching, and I will see you in the next video.